So in this class, I need us to consider another exam revision considering our power supplies we are given. In this case, this was April 2024 exam. On question number 2.1, we are given the power supply of a Samsung TV. So we are given a Samsung TV uses a pi filter. That is a pi type filter. And you are given with the input DC of 18 volts across the first capacitor. Okay, that is across the first capacitor, meaning to say we are given VDC across. Remember, you guys, your normal presentation. So there's an inductor. So meaning to say we're talking about an LC pi filter in that case. But at the first capacitor, the DC is just going to be VDC like that. This is the one that you're given as 18 volts. Then they are saying the filter inductor has an inductance, and the wire resistance is also given, which is in series with the inductor. Okay, remember your LC, guys. It's just like this, where you've got output of the rectifier, and you're going to have the capacitor here, the first capacitor. So the inductor here can be in series, then there will be another capacitor there. So this is the condition that you are given, that it is in series with this one, a wire that is affecting the inductor. So there is an inductance of 5 henries and the series resistance of what? Of 20 ohms together. It's on this inductor. And calculate the output DC voltage. Remember, at the output, that is across what? Across C2, the second capacitor, at a load current of. So when you're given this load current of 50 milliamps, how are you going to calculate the VDC at the output? Okay, this is just 2 marks, guys. Straightforward question that you are going to consider. So in this case, I wanted also to go through your formula sheet as you have these calculations of the VDC at the output, which can be calculated from these 2 formulas. But in this case, cannot consider the RL, R1, whatever that you have. You can just consider the difference that you have because you've got the current. So that's VDC minus IDC R1, which is R1 is that series resistance that we are given, our RS. So with this formula, we can simply apply it to calculate our output there. Okay, so that was a straightforward question, guys, on this 2.1. Okay, so that's 2.1. So you're just going to have, as we saw, the output is just going to be equal to the difference VDC minus IDC RS, okay, which is our R1 according to the formulas given as R1, which represents our RS. So the first one, you're going to be limited because there was a need for you to calculate to have this load resistance, which we are not given, RL. If you are to consider that, you're not having that. So the first one was going to be, this formula that you had in RL that we're using was going to be limited. But this one, we've got everything, just going to substitute. That is, at the output, our VDC is given, which is 18, which is across C1, minus IDC, that is the current now that is given here as 50 milliamps. That is the current that you're going to take there. 50 times 10 to the power minus 3 times R1, which is your RS, and that was going to be 20. So this was going to give us approximately was going to be 17 volts from our calculator, if you simplify this properly. So just like that, guys, 2 marks, I think they just wanted you to be basic enough. Explain the reason why the capacitors in a filter circuit of a power supply are connected in parallel and not in series, and supposed not to be in series with the load. Why? This is because it blocks the AC signal and passes what? DC signal. So it blocks, that is the major part there. It blocks AC signals and passes. So this is going to pass the DC signals. So that is the idea there. So just for 2 marks, guys, there's enough for you to just explain that. And on 2.3, they are saying calculate the voltage drop in the output voltage in the output that is at full load. So they need you to calculate the voltage at full load. If the power supply of 25 volt no load, the voltage at no load is given as 25 volts. Here's a voltage regulation of 8%. The percentage voltage regulation is given as 8%. How can we calculate this? As soon as connected to the load. So remember your percentage voltage regulation? In case that you have forgotten this, remember also your formula sheet you're given. That is the percentage voltage regulation can be obtained V no load minus V full load over V full load times 100%. So that is when the percentage is considered. And the percentage is considered. So with this, you are just going to make the subject or just substitute and calculate, because you're given that the percentage regulation is going to be given from V no load minus V full load. Everything over what? V full load times 100%. So this was given as 8%, guys. So the moment you divide definitely the percentage, this 100% and the percentage that should be given there, you are going to use this as a decimal because you have divided by what? By 100. Or you can just write as it is 8, then they write 100, then you divide. Or you just write as 0.08. You have already divided by this 100. So it is going to be equal to, at no load, V no load, you're given, this is 25, minus that one at full load, which is the one that we need to calculate, over what? The voltage at full load, which is the one that we need to calculate. So there is no substitute for this. We have to calculate it. This is the one that we need. Substituting into the formula, but how can we calculate our VF? We can simply solve this as an equation. It's now an equation that you have. So let's solve. Cross multiply, there's the same as over 1. So you're going to cross multiply 0.08 times this final. It's going to be 0.08 times VF. Then 1 multiplies here everything. So it is going to be 25 minus VF, like that. This is just like this is X and this is X. So these are like terms where you consider the VF to the one side of the equation as it was a negative here. The moment it crosses the equal sign, on the other hand, it will be a positive this side. So we are going to add positive VL, which is a 1, because this is minus 1. So it will be plus 1. So if we add, guys, 1 plus the 0.08, this one, if you add this one to this, it was just going to be 1.008. You have taken this to the other hand. So it's now like this, 0.08 VF plus this VF that we have is equal to 25. So as you are adding, there is a 1 here. So it's just 1 plus this, which was going to be 1.08 V final, which is 25. So how can we obtain this? Simply divide by 1.08 both sides. And that was going to give us the final, which is the full load voltage. That is the voltage at full load. And that was going to be 23.148 volts, just like that. So this is what you're going to have, guys. Just have to make what you're given, the subject, solve for that. You're solving for what? It's just like there is X here. You are solving for X. How are you going to solve for X? You have the formula, substitute, and that's it. Then on another hand, they want you to draw a neat labeled circuit diagram of a shunt voltage regulator and briefly describe its operation. Okay, I explained this in case that you did not watch that. Make sure that you go through the introduction of the shunt voltage regulator on its own. I talked about this. Remember, we presented this, our resistor. So you're just going to have our resistor to the Zener diode. So that was something like this. All right, connected. This is going to be taken to the Zener diode, to the transistor. And this back here, just going to connect it to the transistor. Okay, let's just say this is our transistor here and to the ground, just like that. Okay, so here, everything, guys, I talked about this. So meaning to say, all you just need is to go through your notes, understand each and every part that you have on your diagram here, our resistor, RL to the output. So that's we're gonna have RL here, and here we're gonna have the V out, which is definitely a regulated DC that we are talking about. In this case here at the input, this is the unregulated output of a rectifier that you're going to have here. So this part represents our unregulated, this part is unregulated output of rectifier. Output from rectifier. All right, so this is what we have. So this becomes definitely the input that we have here, which is that regulated and unregulated output of the rectifier circuit to the series resistor, RS, and that's our Zener diode, giving us a voltage across, which is VZ. Okay, this is our Zener diode. It's going to give us a voltage, and the transistor will give us a base bias voltage, which is VBE. And that is the connection there, connected here, just like that. So transistor, you can write as Q. You can write as T1. It's up to the way that you understand. Way that you do understand. And with this part, the question is, briefly describe its operation. So I talked about this guy. They can ask you to draw this, also describe. So remember I said, in terms of the Zener diode, the value of the Zener diode is selected in such a way that the bias BC, this VBE, is supposed to give us a value that is low enough to keep the transistor in an unsaturated condition. All right, so I'm just gonna try and have this statement written down here. So I said, that's the value. So you're gonna consider in this case the value of the Zener diode, which is this Zener diode DZ. So it is selected first. Is selected in such a way that the bias, so we have the bias, which is VBE, affecting the transistor. In this case of the transistor is low enough. Okay, this is of the transistor. So the transistor is Q, just gonna put Q. You can write it as T, depending with the way that you understand. So that bias is supposed to be what? Supposed to be low enough, is low enough to keep the transistor, in an unsaturated condition. So that is the first part of our selection. This is supposed to be in an unsaturated, it's supposed to be unsaturated condition. So with this, we can have the supply. Remember I said if the supply voltage increases, the Zener diode will remain constant, but that base bias, which is VBE, will also increase at that increase that you have there. So if the supply voltage, let's talk of the supply. If the supply voltage increases, the Zener diode, so we're gonna have the Zener voltage in this case, which is the voltage that we have on the Zener diode, VZ will remain constant. Okay, so this will remain constant, but according to the VBE to increase, but the bias, which is VB, I'm just going to write in short, guys, the bias EBE will increase. So that is what you have there in terms of what? Increase in voltage. So the fall compensates for the increase in supply voltage, and this in this way, the output voltage is supposed to be what? Stabilized. That is the major part that you have. So the fall compensate in this case for the increase in supply. Okay, so you're gonna have the increase in supply and supply voltage. And in this way, the output voltage is what? Is stabilized. The output voltage is stabilized. The output voltage is stabilized. So I need us to work with much questions in as much as we can, as we are to revise our power supplies, work with question papers, can be very helpful. Understand how do they ask a question so that even if you're revising your textbook, whatever that you are having there, the source that you are using, you can figure out important questions that they do ask. And sometimes it's actually just a repetition of questions. So the more you work with the question papers, the more that you can understand how are they going to set up the questions in your exams. This is what you had, guys, from our April 2024 till we meet again.